We're skipping over that, sorry. There are other three-dimensional solids that we'll spend time on, but they can't be called polyhedrons because not all of the faces are polygons. Like the cylinder is just like a prism, but with circular bases. A cone is just like a pyramid, but with a circular base. So they have special names, but not special formulas. So you'll see when we start doing volume, they'll act just like a prism or a pyramid. I'm skipping over this. All right, now we're numbering these 1, 2, 3, 4, 5. And it's going to be easier on your notes than it's going to be for me on this screen because you can see them right above that table on your notes, and I'm going to have to keep doing this. If you look at number 1, the octagonal prism, how many faces does it have? How many faces? This octagonal prism has 10 faces. Now, I don't necessarily expect you to be able to see that right away, so let me show you what I'm talking about. That octagon is a face. This other octagon back here is a face, so that's 2. But there's also all of these rectangles that are connecting the 2 octagons are also faces. So there's going to have to be 8 of those rectangles to connect the 2 octagons. So you have 3, 4, 5, 6, 7, 8, 9, 10. 8 rectangles and 2 octagons for a total of 10 faces. Let me clear that out. Now, as far as edges, you can start counting edges. The highlighter might be best for that. This octagon has 10 edges. This other octagon has 10 sides, but every one of those sides is an edge of the polyhedron. So far we have, I think I said 10 accidentally, 8 sides or 8 edges, 8 more sides or 8 edges. So that's 16, but then I need 8 more to connect these vertices. So there's 8 plus 8 plus 8, or 24 edges. The number of edges would be 24. The vertices are the corners. So there's a vertex, there's a vertex, there's a vertex, there's a vertex. There has to be 8 vertices on each octagon. And there's 2 octagons, so there's going to be a total of 16 vertices. So let's get that into that table, 10, 24, 16. As I'm doing them on the other slide, you can just be putting them right into your table. So for number 1 we had, really should have thought of a better way to do this, 10, 24, and 16. For shape number 2, the pentagonal pyramid, how many faces do you see? There's 6, because the pentagon is a face, and then there are all these triangles. There's 5 triangles plus 1 pentagon for a total of 6 faces. How many edges do you see? There's 1, 2, 3, 4, 5 on the pentagon, and then 1, 2, 3, 4, 5 more going up to that apex. So there's 10 edges. How many vertices? 1, 2, 3, 4, 5, and then this one up here, so it's a total of 6. So for the pentagonal pyramid, we have 6, 10, 6. Six, 10, 6. Now here's the thing. I can go do that for every single one of them, and maybe I should. I don't know for sure. But if you'll remember that interactive tool that I showed you at the start of this video where you can go on the website and there's one for pyramids and one for prisms. You can click on different types of pyramids and prisms, and then at the bottom it shows you faces, edges, and vertices. And if you click on them, they'll highlight the faces or the edges or the vertices. So if you're having trouble seeing where these numbers come from, I would go there and or come to the optional zoom so I can help you out. But just for the sake of time, because I don't want to make these lessons overly long, let me fill in the correct numbers for shapes, polyhedrons 3, 4, and 5. And then if you have time to look them over, you can see where these numbers came from. And then there are patterns for prisms. There are patterns for pyramids. You may have already started to notice some of those patterns, which is great because a big part of math is understanding patterns. But there is one pattern that holds for all of the prisms and all of the pyramids. And it was discovered by this guy, Leonard Euler. It looks like it would be pronounced Euler, but it's actually Euler, like this, like oil, E-R, that's how you say his name. And he discovered a relationship between the faces and the edges and the vertices of any polyhedron. And I want you to pause if you want to see if you can find it yourself. Almost in every single class I'll have one student find it. If you have time, you pause and see if you can find the relationship, and then hit play when you're ready to see the answer. The answer, Euler's polyhedron formula, is that if you take the faces and you subtract the edges and you add the vertices, you always get 2. And so 10 minus 24 plus 16 should equal 2. 10 minus 24 is negative 14, and negative 14 plus 16 is 2. 6 minus 10 is negative 4, and negative 4 plus 6 is 2. 4 minus 6 is negative 2, and negative 2 plus 4 is 2. 8 minus 18 is negative 10, but when you add positive 12 to negative 10, you get 2. 5 minus 9 is negative 4, but negative 4 plus 6 is also 2. And so you can use that formula to check your work, and you will be using that formula to check your work. I'll show you what I mean in a minute. We're skipping past this. On tonight's assignment, which I should have pulled up, let me start with the easier side. The back side is actually the easier side. The back side, these four say to identify each polygon and tell if it is regular. So you name that shape, you name the shape, that's the first part, and then you tell me yes or no. Is it regular or is it not regular? And if you don't know what I mean by regular, go back to the beginning of this lesson. That was the first thing we talked about. Then you name this shape and tell me whether or not it's regular. You do that for all of these. For these, you've got nets. And we looked at nets when we looked at those interactive tools on Friday. But you can also look at some of them either on that by revisiting that interactive tool. Yeah, that's pretty much the only way at this point. But it basically means if you folded up these faces and made a three-dimensional solid, what would you name the solid? What would you get? What would you get when you folded up these four triangles? What shape would you have? Now that explains the back side. The front side, you have to do two things on these. Name the figure, like this one. Is it a prism or is it a pyramid? And once you know that, look at the shape of the base, and that will tell you what kind of prism or pyramid. So they should all have two names. How do I say this without giving it away? Let's just do the first one. Okay, this has two parallel and congruent triangular bases. So that's what makes it a prism. And because those bases are triangles, it's a triangular prism. Then you want to count the faces. Those two triangles are two of the faces, and there's three more rectangles. So 2 and 3, so 5 faces. The edges, there's 3 edges for each triangle, and 3 more connecting the two triangular bases, so there's a total of 9 edges. And the vertices, 3 vertices on each triangle, so a total of 6 vertices. But then you need to substitute those numbers into Euler's formula. So 5 minus 9 plus 6 equals 2. 5 minus 9 is negative 4. Plus 6 equals 2. And negative 4 plus 6 is 2. That's how you check your work. You should be doing these for each one to verify your count. It's a way to check whether you counted correctly. Okay, so that's how to do that assignment. Of course, there's a homework help video on the blog like there always is, so use that resource as well. Okay, class dismissed.